Alright, what's up guys? It's Probability by Pitman Chapter 2, Section 2, Problem number 6. Okay, so to estimate the percent of district voters who oppose a certain ballot measure, a survey organization takes a random sample of 200 voters from a district. If 45% of the voters in the district oppose the measure, estimate the chance that exactly 90 voters in the sample oppose the measure. Okay, so before we even take care of that, it should be pretty obvious that this is a binomial distribution of n equals 200 and p equals 0.45. So it's binomial because each event is pretty much independent and it's either a success or a fail of whether they oppose the measure or not. So we have 200 total people, so n equals 200, and the probability of a fail, of a success, which is opposing the measure, is 0.45. Okay, cool. So since we know we're going to have to be using phi, or the CDF of our normal distribution, we might as well just calculate mu and sigma right now. So mu for a binomial distribution is just n times p, so 200 times 0.45, which is equal to 90. Okay, cool. And the sigma is equal to root npq. So sigma is a standard deviation. It's equal to root npq for a binomial distribution, which is just 200 times 0.45 times 0.55. Okay, cool. So now we can actually do our work. So exactly 90 voters in the sample oppose the measure. So we can just use our phi, which is just the CDF. So we'll do 90, and we'll use our corrected factor of a half, then minus the mean, which is 90, over sigma. I'm not going to write it out, but you can just substitute that in there. Minus phi, 90 minus 1/2. So we'll use a corrected factor of negative half instead. Then the rest will be the same. And if we keep going, it'll simplify down to half over sigma minus sigma negative half sigma, and it should be fine if we just leave our answer like that. I guess you could simplify it a little further, but honestly this is fine. Okay, cool. Part B. More than half the voters of the sample opposed the measure. So just as a reminder, the CDF of a normal distribution is just the area to the left. So if we chose, for example, this point A, the CDF of A is the area to the left of it on the normal distribution. So when we're asking for more than half the voters in the sample oppose the measure, we're asking for this segment. So to get that, we can take the complement of this CDF. So we'll do 1 minus phi, and then we're saying more than a half. So if half of 200 is 100, we'll say more than half is 101, so we just want to include the 101. So we'll do 101, and then we'll have our corrected factor of a half, minus our mu, which is 90, all over sigma, which I'm not going to write out once more. And if you simplify that, it should be equal to something like 9.5 over sigma, and, or wait, sorry, that's 10.5, my bad. Okay, sorry, 10.5 over sigma, and then if you just use a calculator, you'll get your answer. Alright, cool. I hope that helped, and thanks for watching.